we have to find the integral of 1 over x squared times the square root of x squared plus 4 dx. So first things first, we have to be familiar with a couple of trig identities. So we have to be familiar with 1 over sine x is equals to cosec x. And then you have to be familiar with 1 over cosine x is equals to secant x. And also there's 1 over tan x equals to cot x. Other identities you have to be familiar with is tan squared x plus 1 is equals to secant squared x. So with these, remember these, and then we're going to use them later. But with these, we can be able to solve this question. So first of all, we have to draw a triangle just to visualize what's going on here. Usually you just need to know these three, which is if you have x squared plus a, then you're gonna substitute x with a tan theta. Usually this is what you need to just remember, but in order for you to just visualize what's going on, we can draw a triangle. From this triangle, we can get an idea of what's actually going on here. So how do we get a squared? A tan x, a tan theta. I mean, so if this is theta, what we can do is we can look at what we're given here, which is x squared plus 4. So remember that if I have a rectangle triangle, I have A, B, and C. So how can I find the value of C? The value of C is a squared plus b squared. Alright, so the hypotenuse will be a squared plus b squared. So notice that the hypotenuse is one side squared plus the other side squared. And what do I have here? I have x squared plus 4 squared. So this is one side squared plus another side squared. So I can use that. So it was x squared plus 2 squared. So I have x and I have 2. So this will give me x squared plus 2 squared, which will give me x squared plus 4. So this is how I get this. Now I can write this in form of, this means that I can write tan theta is equals to x over 2. So, and then I make x subject of the formula, which means I have x is equals to 2 tan theta. You see, 2 is my a, and then tan theta. So this is how I get a tan theta. If I'm given x squared plus a, you notice that this is a is 2. This means this is a squared. So 2 there. So that's why I have x equals to 2 tan theta. But people normally just memorize this, but I prefer knowing how to get it from this triangle right here. So from this we can substitute, wherever there's x, we can substitute 2 tan theta. But before doing that, we need to find dx as well, so that we can have everything in terms of theta, because I need to substitute theta here. So I'll have 2 tan theta here, 2 tan theta here, 4 there, and then here I'll have dx. So I need to have dx in terms of I need to substitute something for dx. So I need something d theta basically. So in order for me to get d theta, I need to take a derivative of this in terms of theta. So in doing that, I'll have dx is equals to 2 secant squared theta d theta. So now I have dx. So now I can go and substitute everything in there. So I'll have 1 over x squared, which will be 1 over x squared is my 2 tan theta squared, then the square root, and then again x squared, 2 tan theta squared plus 4. Let me just make sure I'm not making any mistakes. So yeah, and then dx. Okay, yeah, and then dx, place of dx is 2 secant squared theta d theta. So it's times 2 secant squared theta d theta. So I can just move this right there to make things a bit better. So it's 2 secant squared theta, and then I can write d theta there. Okay, perfect. So I square, let me just simplify everything at the bottom. So 2 secant squared theta. So in simplifying everything, I have 4 tan squared theta, and then I have 4 tan squared theta plus 4 d theta, and then I need to simplify this part. I need to take the common factor, which is 4, so that I'm left with the tan squared theta plus 1. So 2 secant squared theta over 4 tan squared theta. So I have 4 tan squared theta plus 1. So now when I have this, I can simply change tan squared theta plus 1 into, let's see, tan squared theta plus 1. There we go. Tan squared theta plus 1 into secant squared theta. We see tan squared x plus 1 is equal to secant squared x. So tan squared theta plus 1 is equal to secant squared theta. So therefore I have 2 secant squared theta over 4 tan squared theta. So I can take the, okay, I'll do it later. So this will give me secant squared theta d theta. Okay, from here I can just take the square root here. So if I take the square root, remember that if I have something like 4 times 6 times 9 basically, I am allowed to just separate them and take the square root of 4 times the square root of 9, which means I can have 2 times 3, therefore giving me 6. instead of multiplying 4 and 9 getting 36. And so I can do it this way instead of just doing it like that. I can do it this way. So which means that even here I can take the square root of 4 on its own and then multiply by the square root of secant squared theta. So if I take the square root of 4, I get 2. Then square root of secant squared theta is just secant theta. So now the square root is gone, which makes life a lot easier. So this 2 can cancel that 2. Okay, wait. Let's just use a different color there. So this 2 will cancel that 2. And then I can move my 1 over 4 to the front here. Just focus on these. So my secant squared theta can cancel out the secant theta. So I'm left with secant theta there. And secant theta here is gone. So I can cancel the squared with that. So therefore I only have secant theta over 4 tan squared theta. Oh, sorry. The 4 is there. D theta. So I can change this to, remember, secant theta. You see, secant theta, secant x equals 1 over cos x, which means secant theta will be 1 over cos theta. And also, okay, yeah, I'll just do that. So I have here 1 over 4. So I have secant theta, and secant theta will be 1 over cos theta. That's secant theta times 1 over tan square theta. But 1 over tan square theta is basically 1 over, it's basically it's the same as 1 over sine squared theta over cos squared theta, which is the same as cos squared theta over sine squared theta. So just so that you're not confused, let me write it down. So 1 over tan squared theta is the same as 1 over sine squared theta over cos squared theta. So you see you have a fraction at the denominator, which means you can just move the denominator of that fraction on the denominator to the top, because you can also rewrite this thing as 1 divided by sine squared theta over cos squared theta, which means that I can write it as 1 times cos squared theta over sine squared theta. So therefore I can write 1 over tan squared theta as cos squared theta over sine squared theta. So therefore I have 1 over 4 to secant theta. Okay, let me just leave it as cos theta, sorry, because I changed it to 1 over cos theta. So cos theta times cos squared theta over sine squared theta d theta. I forgot about d theta here. Okay, it's fine. So I can cancel out one of my, so in the square to cancel out that cos theta there. So I'm left with 1 over 4 cos theta over sine squared theta. D theta. So from here, we have to work a little bit of magic, and we have to do some substitution. So what we're gonna do is we're gonna separate these two. So we're gonna have cos theta over sine theta. Then I'm gonna separate it with the other sine theta. I'm gonna separate this sine theta with this one. So I'm gonna have cos theta over sine theta times 1 over sine theta d theta. It's so that I can write it as, you see, cos theta over sine theta is basically 1 over tan theta. And remember that 1 over tan theta gives me cot theta. So 1 over tan x gives me cot x. So I can write that as 1 over. So I can write this as cot theta. And 1 over sine theta gives me cosec theta, and then d theta. And then from here, I can let u be equals to cosec theta. So if I let u be equals to cosec theta, I have to find du as well. Because if I'm going to let u be equals to cosec theta, so this means here I'm going to substitute u, but I have d theta there, so I need to find d theta as well. So in order for me to find d theta, I have to take the derivative. So you have to take du over d theta of sec theta. So it's either you can memorize some of these trig. I think there's a table that you can find online of trig derivatives, but if you're failing to memorize it, you can just determine. So you can calculate it by just taking. So you can. Okay, let me just do it with separate color and let it be separate piece of working. So I can do this. So I can take d over d theta of, instead of writing, of cosec theta, I can write it as d over d theta. Instead of writing it as cosec theta, I can write it as 1 over sine theta. 1 over sine theta. So remember, when taking derivatives of fractions, what do? So we take the derivative of the top part, we multiply with the bottom part, and then minus the derivative of the bottom part times the top part, and then we divide by the square of the denominator. We call that the quotient rule. So that's what we're gonna do here. So we're gonna take the derivative of the numerator here, which is 0. So I can write it here, which is, okay, no, let me not write it there. Create some space for myself. So it's going to be 0 times, so it's 0 times the numerator, which is sine theta, minus the derivative of the numerator, which is cos theta, times 1 all over the denominator squared. So here this will give me 0, and then this means I'll have negative cos theta over sine squared theta. And I can always write this as, again, I can write it as cos theta over sine theta times 1 over sine theta. So I can write this as cot theta, sorry, there's a negative. Yeah, there's a negative. So yeah, it's going to be cot theta times cosec theta. So negative cot theta times cosec theta. So this is what I have as my derivative of cosec theta. It's negative cot theta times cosec theta. So I'll continue from there. So du is therefore negative cot theta cosec theta d theta, and then I divide both sides by negative cot theta cosec theta to have d theta as the subject of the formula. So therefore I have subject the equation, sorry, which means I have du over negative cot theta cosec theta. So now I can substitute this in place of d theta. I can substitute that. So where's my, okay, so I have 1 over 4 integral cot theta cosec theta over 4 integral, and double check, okay, yeah, cot theta cosec theta and then I have dx, d theta I mean. So in place of d theta, I'm going to substitute this, which is du over negative cot theta cosec theta. Now you'll see that I can easily cancel out cot theta, and I'll move the minus sign to the front. Negative 1 over 4. Okay, and then remember that I made cosec theta be equals to u. Where is it? There. Let u be equals to cosec theta. So I substitute u in place of cosec. So I have, or I don't even have to do that because I can easily just cancel out cosec and cosec. But if it could not cancel out, then I'll just substitute my u there and then determine my derivatives there. So I'm left with du. So from there, I just take the antiderivative of, basically, there's a 1. You see? So I take the antiderivative of 1, which is just u. Negative 1 over 4 u plus c. But I do not want the antiderivative of u. Instead, I want the one of x. But in order for me to get to x, I have to substitute back theta. And what was theta? Theta was, for u in terms of theta, was cosec theta there. So I come back and substitute cosec theta plus c. And still, I want my antiderivative in terms of x. So what is cosec theta? It is 1 over 4 times 1 over sine theta plus c. So what is sine theta on my triangle here? Sine theta is opposite over hypotenuse, which is 1 over x root of square root of x squared plus 4. So it's x over square root of x squared plus 4. Negative 1 over 4 times 1 over x divided by square root of x squared plus 4. So this is the same as 1 over 4. This is the same as times 1 divided by x over square root of x squared plus 4, which is the same as 1 times root of x squared plus 4 over x. So now I have, why do I keep forgetting the negative? 1 over 4 times the root of x squared plus 4 over x. So therefore I have negative root of x squared plus 4 over 4x, and that's my antiderivative. Oh, and sorry, I forgot to add a plus c right there, so make sure you've got plus c.